Good morning, girls, and welcome to Term 2 of Antimetric AP Maths. And we're going to be starting off with a new section, quite a nice section, Calculus. And the first two lessons in your schedule are really just basics and kind of a introduction to your calculus. So there are concepts that you will need at a later stage. So the first thing we're going to look at is composite functions. Now, a composite function is effectively when you're given two functions, or three sometimes, or as many as you need really, but we normally just deal with two functions or three functions. You could be given f of x and g of x, and a composite function means that you substitute one function into the other function. So you could either substitute function f into function g or function g into function f, and they would give you then different graphs that you would be able to sketch and then analyze. Right, so the definition is as follows. If f and g are two functions, two different functions, then the composition function of g with f is given by g of f. So this symbol here, we refer to that as of, is equal to xy such that y is equal to g of f of x. Now look what's happening here. F comes second in the g of f. So because f comes second, it means that we substitute f into g of x. Now the definition itself isn't as important, but what is important is that you can apply it in the example. So let's apply this to an example now. Right, so look at example 1. If f of x is equal to x squared plus 2, so that's a parabola, and g of x is equal to root x minus 5, that is half a parabola on its side, which you will get to at a later stage, determine a, g of f of x, b, f of g of x, and c, g of f of 2. Now, just to show you some notation, you will see that sometimes, if we look at a, they will show this in a bracket. So it'll be g of f bracket and then bracket x. It means the same thing when it has those brackets around the g of f. Right, so I've color-coded it for a reason. So what we're going to do is we're going to rewrite for a the expression like this. It's going to be g of, and then inside will be the f of x, the pink one, and that'll be inside the function of g. So the first thing is, the pink function is f of x. We're going to substitute that in to g of x. Right, so it's going to be g of, and then the pink function, which is x squared plus 2, goes in place of f of x. And after that, we then have to substitute the x squared plus 2 into g of x. So that means x squared plus 2, this x squared plus 2 needs to be substituted into g of x wherever you see the x. Right, so it's going to be root x minus 5 is g of x, but in place of x now needs to be x squared plus 2 minus 5. And then we simplify that. So that becomes x squared plus 2 minus 5 is negative 3. Example B, f of g of x. Again, we can rewrite this in a form that's a little bit simpler to understand. So it'll be f of, and then g of x in the middle. That's what's getting substituted into function f. And we can then substitute. So the red function is going to get substituted into f of x. So the red function is g of x, which is the root of x minus 5. And then we're then going to substitute the root of x minus 5 into, so this root of x minus 5 is now going to get substituted into that x of the x squared plus 2. There could be more than one x in the function. For example, if this f of x was x squared plus 3x plus 2, we would have to substitute the root x minus 5 into the x of the x squared as well as into the x of the 3x. Okay, but in this case, it's just the x squared. Right, so we can then substitute that in by saying that this then equals, and I'm going to, because the x squared is because the x is squared, I'm going to put it in a bracket, so it's going to become the root of x minus 5, that's g of x, squared plus 2. And then now we can simplify this. So the square and the square root cancels out to give us x minus 5 plus 2, which is then x minus 3. Okay, so you can see that it does look different to the previous one, and that's because the order has been switched. The first one was g of f of x, and example B was f of g of x. Example C, If we first put it into a format that's easier to understand, so it'll be g of, and then f of x, or in this case, f of 2, we can then straight away substitute the 2 into the x value of the function f. So the next step then is going to be g of, and then the pink function, which is f of x, is going to be 2 squared plus 2. Okay, and then we know we can simplify that before we carry on. So 2 squared is 4, plus 2 is 6. So now it's just g of 6. And so into function g, we substitute 6. So it's going to be the square root of 6 minus 5, which is the square root of 1, which equals 1. Now, just to show you a variation on this, if I erase what I've just done, so I'm going to take all of this out, if you were clever, you would have seen that this is the same format as example A. So we can actually go straight to an answer. Okay, so what I mean by that is recognize that in question A, we had g of f of x. Now this follows the same format in C, g of f of 2, which means that we've already shown that g of f of x, the composition, is the square root of x squared minus 3. So it means that for C, the composition is actually the square root of x squared minus 3, but in this case, x is 2. So we can straight away substitute the 2 into x, and that gives us 4 minus 3, which is the square root of 1, which is also equal to 1. Right, before I go on to the next example, I just want to speak briefly about inner and outer functions here. So if we look at a question A, particularly in the second step where I've written it as a function of the other, we can see that f of x is the inside function because it's inside function g. G then becomes the outside or the outer function. When we look at B in the second step, g of x is the inside or the inner function, and f then becomes the outside function. And the outside function is the function in which you substitute the inside function. Example 2. Find functions f and g such that f of g of x is equal to x squared minus 1 to the power of 5. So here they're asking it to you in the other way, in the other direction at least. So they've given you the composite function, and they now want you to determine what the original two functions are, function f and function g, that would result in this combination. So the first thing is I'm going to rewrite the left-hand side. That means that f of g of x is equal to x squared minus 1 to the power of 5. Okay, so we've got two different things we've got to look at. Firstly, what is the inside function? So the inside function is g of x. In other words, that's the thing that you would substitute inside the other function. So look on the right-hand side. You should be able to clearly see that the inside function is in fact what is inside the brackets. In this case, x squared minus 1. So that means that that g of x is equal to x squared minus 1, and the outer function then is whatever is outside the square, outside the bracket. So in this case, it's the power of 5. So therefore, it means that the function f of x is equal to x to the 5. Okay, so to understand that, see where it comes from. We have to substitute g of x into f of x to get this expression. So if we look at my solutions here, the pink function, g of x, which is the inside function, if you substitute x squared minus 1 into the x in f to the power of 5, you end up with this expression, x squared minus 1 to the power of 5. Okay, so I'm going to show you just quickly on the right-hand side how we would determine that. So f of g of x, okay, that equals f. Now let's put g of x in as we've worked it out. So that's this one here, the x squared minus 1. We're going to put that in to f of x. And then x squared minus 1 needs to now substitute into f of x, this function here. So then that becomes x squared minus 1, and we must use a bracket because it is all raised to the power of 5, which gives us our original expression. Right, so now I'm going to show you how this function would look if we'd put it the other way around. Okay, So what I mean by that is if we erase the f of g and we now make that g of f, then it's going to work almost exactly the same way, except now your functions will be swapped around. So now f of x is the inside function. That means f of x will now equal x squared minus 1 as the inside function, and the outside function will be g of x, which in this case is x to the power of 5. So it's important you get the order right as to which is the inside function and which is the outside function, because we've shown now that in this particular scenario, f of x is x squared minus 1, the inside function, and g of x is equal to x to the 5. So if you had to do the composition the other way around now, so instead, you now say f of g of x. Now let's have a look. This means that the inside function is now g of x. So it's going to be f, and then put x to the 5 on the inside, and then that will be now x to the 5 substituted into function f wherever you see x. In other words, we're substituting this x to the 5 into this x in function f. All right, so effectively that means we're going to now say x to the 5 in a bracket raised to the power of 2 minus 1. Simplifying that gives us x to the 10 minus 1. So you can see it's completely different if the order of f and g or the outside and the inside functions are different. Right, I hope you understand this lesson. Like I said, it's quite an easy lesson to ease you in, not too much work. You have 2 days until the end of Wednesday, and I will post the solutions to exercise 1, page 134, in the early evening on Wednesday. You only have to do all of A to D. You can stop when you get to the end of D.